We're going to continue with our unit on chemical equations today. Last time we introduced our learning goal through inquiry and exploration. Students will be able to differentiate between chemical and physical changes. We talked about that last time. And we also introduced writing and balancing of chemical equations last time. We're going to balance some more complex chemical equations today. You will get a lot of practice and be ready for your quiz. Later in the week, we'll get into classifying and predicting chemical equations. All the objectives in the chapter are relatively straightforward, and with practice, you will be very successful in mastering these basic concepts. So last time we introduced balancing chemical equations, and in your Do Now, you just wrote a chemical equation illustrating that particular reaction. Our focus today is going to be on writing and balancing chemical equations that are a little more complicated. The first set that you see on the screen here have some similarities. Name one similarity that you see in these four chemical reactions. H2O. They all have water as a product, so that's one thing you see. What else?
They all have carbon dioxide.
They all have carbon dioxide. So in all four equations, you can see that the products are CO2 and water. What's something else that you see?
They also have the, I forgot what it's called, but the O, the Q, and it. Oxygen, yeah. But is it a different thing if it has two?
No, okay, so they all have oxygen gas, you are correct. They all have the diatomic element oxygen.
Okay.
Okay, you are correct. So you can see three commonalities right away. Also, if you look at the first reactant, here and up at the top, those are hydrocarbons, C and H's with some subscripts indicating how many of each you have. Hydrocarbons are very common. Propane for your grills to barbecue, octane when you go to get gas in your cars. And here we have oxygen derivatives of hydrocarbons. You can have nitrogen derivatives of hydrocarbons, and these you tend to find in some drugs that of course you're not using, as well as nicotine, etc. So you will tend to find those particular elements generating compounds that can be very, very dangerous. So we're going to focus on balancing these equations. I've got a couple of tricks to show you that I think will be very helpful to you. It'll make the balancing much easier. You're all really stellar at math, so I think you will like the tricks. I have the equations printed out here. I'm going to work through, and I'll blow it up as big as you need it so that you can see. Little bit bigger. All right, so in this first reaction, and this is a combustion reaction when you have a hydrocarbon reacting with oxygen gas to generate CO2 and water, and we'll talk about the different classes of reactions next time. When I go to balance these can be a little bit trickier. So I usually will make my chart. Some of you may not be using the chart very much because you're finding it easier to just balance back and forth, and that's fine. As we talked about yesterday, we typically make a table, R for reactant, P for product, the atom in the middle. And as we talked about yesterday, every time you have a capital letter, you have a new atom. We talked also about counting the atoms as we did back in chapter 2. How many carbons on the reactant side? 4 is correct. Hydrogen, oxygen. On the product side, we said yesterday that there was a common feature that you see. How many carbon? Hydrogen, oxygen, Good, and you're going to see that 1, 2, 3 feature in these combustion type of reactions in each case. Now, when you go to balance, what do we call the numbers that we can put in front of those substances? Coefficients. And when you go to balance these types of equations, you want to do the C, the H, and then the O. So let's start with the C. We have 4 C's on the reactant side. How can we balance the carbon? Put a 4 where? Coefficient of 4 in front of CO2 is correct. That's going to make 4 times 1 is 4 carbon. 4 times 2 is 8. Plus 1 is 9 O's. Be careful with the O's. Those are the trickiest because they're in multiple places on the product side. Now balance the H. We have 10. We have 2. The approach. What times 2 is 10? Coefficient of 5 in front of the water. 10 H's. Recount the O's. How many O's are there on the product side? Four times 2 is? Plus 5 more is? 13. Careful with the O's. What's your question?
I don't get the O's.
The O's as we counted initially?
Yeah.
Okay, so the O's initially, if I block these 2 out, there are 2 O's in the CO2 plus 1 O in the water is 3. When I put the 4 here, there's 4 times 2 is 8 plus 1 more is the 9. And then tell me how I got 13.
You put a 5 there.
I put a 5 here, so that makes 5 O's here. And how many O's here? You're going to multiply the coefficient times the subscript. So 4 times 2 is? 8. Plus 5 more is? 13. All right, so coefficient times subscript, but you have more O's here. So plus the 5 times 1, 8 plus 5 is 13.
What happens if it's like hydrogen peroxide, like O2? There's 2 O2s.
Then you would count them both. And you'll see the O count kind of funky in this one, and I think that's where you're going. All right? Additional questions? All right, we're not quite balanced yet. What isn't right? The O's. And this is the tricky wiki part. Something times 2 has to equal 13. So there's a couple ways to approach this. So 2 times a coefficient, which I'm going to call x, that'll represent my coefficient, is equal to the total we have on the product side. So think simply as a fraction, x is equal to 13 halves. Can you have a coefficient that is a fraction? No. We said they're whole numbers, not 0. So when you have a fraction here, in this case of 13 halves, you are going to multiply every coefficient by the denominator in that fraction. So I'm going to multiply every coefficient by 2. I'm going to get 2 butanes, 13 oxygen, 8 CO2, and 10 waters. And now I'm just going to double check on my counts. 2 times 4 is 8. 2 times 10 is 20. 13 times 2 is 26. 8 carbon. 16, careful here, 8 times 2 is 16, plus the 10 more on the O is 26. 10 times 2 is 20. And now you have a balanced equation. Now some kids love this fraction method, some kids not so much. If you're having trouble with the fractions, you can put a 2 here and try and keep going. Sometimes it works, not always. It's very much trial and error, as you see in a lot of science type classes. Questions on the first one? All right, let's try and do the second one. As we talked about yesterday, a simple chart. How many C's on the reactant side? 18. How many H's? How many O's?
2.
And what do you know about the product side? The CHO is always 1, 2, 3. Makes it easy. Okay. Balance in the same manner, C then H and O. What do we do?
C first.
C first. How do we balance the C? 18 in front of the? You got it. Coefficient of 18 in front of the CO2. Will, help me with those O's. Let's make sure we've got it. 18 times 2 is 36 plus? You got it. So that would be?
37.
Perfect, 37. Now we're going to do the H's. We've got 38 on the left. What times 2 is 38? 19 is correct. That's a sloppy 9, sorry. We've got to recount the O's. Brave soul to count the O's.
Oh.
Go for it.
Me?
Yeah.
Oh. Oh, okay. So wouldn't it be just 19 plus 36? And then, yeah.
So 18 times 2 is 36 is correct. Plus 19 is? 55 is correct. All right. So again, 2 times x, the coefficient, is equal to 55. What are we going to put here initially? 55 over 2. And then we have to multiply each coefficient by what? 2. Don't forget to multiply the first one. That is a common mistake that kids make. Be careful. So you've got your coefficients, and then you just need to double check that your counts are correct. We've got 36. 2 times 38 is 76, and 110 O's. We've got 36 carbon, 76 H's, and 72 is 110 O's.
This is a little off topic, but what's the point of doing this?
To balance equations, where this is, it's a good question, it's not off topic. Where this is leading to is in the next chapter that we cover on stoichiometry. and we'll be doing it in the lab as well, you will be given masses of these two substances, and you will want to predict how much of these substances will get made, and then you will mix the substances together. You will generate product, you'll mass it, and you'll see how good of a job that you did in the lab. It's called percent yield as opposed to percent error, and you can see how good your chemistry is in the lab. And in a college lab, that's exactly how you would be graded on your percent yield. You want to generate at least 90% of what you predict. And that becomes very important in terms of generating product, whether it's in drug manufacture, food manufacture, etc. So it's an excellent question. But in order to be able to figure that out, you have to be able to balance the equation. All right, on your next one, this one's a little tricky, but I know you'll be successful. What is the key difference between this equation and this equation? What do you got, Nick? There's two O's. What do you mean two O's in two different places? Okay, so for the first time you're seeing an O in the first substance, the hydrocarbon. So this is just going to require one additional piece. And what we're looking at here same approach. How many C's on the reactant side? How many H's on the reactant side? How many O's? How about on the product side? 1, 2, 3, you got it. Nice little quickie. As we talked about, quick way to do it. First thing we need to do is what? C's. So what are we going to put in front of the carbon dioxide? 5 is correct. How many O's, Will?
11.
You got it now. Good job. All right, H's, we've got 10 on the left. What do we put in front of the water? And Will, what's our O count?
Wait. I got it.
He can do it.
It is 15.
You got it. Good job. All right, here's the key difference. Previously, we were doing 2x is equal to this total. But don't forget about that O. Not 3x, because they're not all together and the x represents the coefficient. Be careful. How about 2x plus 1 is equal to 15? 2x is equal to 14, and x is equal to 7. Lot of very simple algebraic concepts, algebraic math built in to this lesson. And you are done. You can check now here, and you're going to have 14 plus the 1 here is 15, and you have a balanced chemical equation. One more together, or you want to try yourself? Go for it. Give it a shot. And again, you've got it on the screen. You've got it on your Chromebooks. And see if you can balance it. How we doing?
Oh, we have it.
It's there. It's this one. Right at the top. I'll highlight it in yellow, okay? There you go. So you ready for the answer?
Yeah.
So what I got on this one, 2, 17, 12, and 12. Yes?
Yeah.
Okay. Try one more. And you will master this. It does take a little practice. The one you are doing now is in blue on the screen, and you also have it on your Chromebooks.
Does that say C8?
All right, how do we do with this one? You got it?
16,
Not yet? Another minute?
Almost there.
All right, let's reveal. On this one, you have 2, 23, 16, and 16 as your coefficients. Okay, so if I ask you the coefficient of water, 16. If I ask you the coefficient of oxygen gas, 23, as we talked about the other day. So this is balancing combustion reactions. That's probably as tricky as anything you will see. I'll give you one challenging problem on your quiz, although I know you'll be very successful with it. There are some additional problems here that I'd like you to work through. Those are a little more complicated, although I do think you'll be able to do them. I also want to indicate on the classwork that I gave you yesterday, most of you did 1 through 10. You can do 1 through 20 on that classwork now. In a second classwork that I will give you in just a minute, you can do 1 through 14. You just won't do the classification piece yet. At this point, hopefully you do feel very comfortable writing and balancing chemical equations. That's what you'll be assessed on. We'll get into the classifying and predicting piece next time. That can be a little bit challenging, but you're very bright, and I feel very confident that you'll be successful with it. We still have some time. I'd like you to try these problems before you break out. Actually, you can break out into your groups now, and you can work through both equations shown here. I'll reveal the answer on the screen in a little bit, and I'll give you your secondary classwork to help you prepare, and hopefully you'll feel very comfortable with it before you walk out today and show me on your quiz later in the week.